Hi there. So in this video, we're going to be looking at solving quadratic equations using the square root property as well as the quadratic formula. And if you recall, back in a previous section, a previous unit, we have already solved quadratic equations earlier by factoring. Okay, so I'll just revisit that here in example 1 just to let you know that what we've already learned can still be utilized in many cases. And that's the way that I would always solve first. I would use try to solve by factoring the square root property, and then if you can't do either one of those, then go to use the quadratic formula. So here in example 1, it says we'll solve this by factoring. So remember, in order to solve by factoring, you need to be equal to 0, and we are here. So let's get our pen going here. So immediately then start with my guess and check. The only way to multiply to give me x squared, x times x. Most common way to give you 4 is 2 times 2, but we're trying to get a 3 on the inside, so another way to multiply to give you 4 would be 1 times 4. So that on the outside and inside you got a 4x and 1x, and your goal is a negative 3x, so the only way to get that negative 3 is you got to make your 4 negative. And then 1 times negative 4 would give you a negative 4. So that tracks. So now we set both of these equal to 0. So if you remember, we set x plus 1 equal to 0, x minus 4 equal to 0, and we solve for x in both cases. So we pull our 1 over. So one of the solutions we're getting is x equals negative 1. Pull the 4 over. The other solution, x equals positive 4. And so those are our two solutions. So here we'd have two solutions, negative 1 and positive 4. Okay, so that's something that that's how you've previously learned how to solve quadratic equations. Now, sometimes we can get there even quicker if we don't have that middle x term, and that's where we would want to use the square root property. And you mainly use the square root property when you have x squared equaling some number a. And so from there, you have just two solutions where you just take the square root. So for example here, when I have x squared equals 4, in order to solve that, I take the square root of both sides, and so the square root of x squared is just x, and then over here I've got the square root of 4, which is plus and minus 2, right? Because positive 2 squared gives me 4, and negative 2 squared gives me 4. So whenever you're solving, then you're going to utilize both the positive and the negative answer here. So I have two solutions then, positive and negative 2, okay, as my answers. So if we come down to example 2 and it says solve this using the square root property, it means just to simply solve for x, and you don't have to do any factoring here because you've got a letter equaling some number, so you can just get closer and closer to getting that x all by itself. I want to get rid of the squared, so I square root both sides. Square root of x squared, just x. Square root of 9, don't forget your plus and your minus, 3, because positive 3 squared gives me 9 and negative 3 squared gives me 9. And those are my two solutions, positive 3 and negative 3. All right, so then let's come on down below. These are the steps for solving quadratic equations using that square root property. I'm just going to flip it over and I'm just going to talk you through these steps, okay? So our first, you always want to try, if you just have it where you have just one letter in your equation, then you can tackle it as letters on one side, numbers on the other. So we're going to solve each quadratic equation using the square root property here. We're going to give exact answers and approximate answers rounded to 2 decimal places when needed, okay? And you can check your answer in the original solution. All right, so in letter B here, if I want to solve for x, I'm going to get letters on one side, numbers on the other. So I'm going to take 49 over. And technically that x squared minus 49 could have been factored, okay? But I'm just using that square root property now. Now I'm left with x squared equals 49. Get x all by itself. I'm going to take the square root of x squared, just x. Square root of 49 plus and minus 7. So those are your two solutions. Okay. Let's move on down to letter D just below it. I'm just going to do this right-hand column on this one. All right, so my goal is to solve for n here. I already have it. Quantity squared equals 49. So let's get that n out from underneath the or out of the parentheses. So I'm going to take the square root of both sides. So then the square root of something squared just gives me n plus 1. And on the right-hand side, I have plus and minus 7. So then in order to get n all by itself, I'm going to subtract 1 from both sides. So n equals negative 1 plus or minus 7. So essentially what that means then is you have negative 1 plus 7 and you have negative 1 minus 7. So negative 1 plus 7, that's going to give me a positive 6. Negative 1 minus 7, it's going to give me a negative 8. So those are our two solutions, 6 and negative 8. All right, and then I'm going to do one more here with you in letter F. I want to get closer and closer to getting that y all by itself, so I'm going to take that 4 over. So the square root, 3y minus 1 squared equals 33. And then I want to take the square root of both sides. So then square root of something squared is just 3y minus 1. Anytime you take the square root, you put a plus or minus. That can't be reduced any further, so I'm just going to have to leave it at the square root of 33. There's not a number in my list. I can't take this perfect square root of 33, and there's not a number in my list that would help me reduce it. So then I just want to get closer and closer to getting this y all by itself, so I'm going to add 1 to both sides. So 3y equals 1 plus or minus the square root of 33. And I'm going to divide by 3. So your two solutions then, your exact solutions are 1 plus or minus the square root of 33, all divided by 3. And then what would happen is this would be your exact solution. This would be exact. And then to get your approximate solution, you'd have to put it in your calculator twice. It would be 1 plus the square root of 33, and I'd probably just hit enter. You got to use parentheses. I'd probably do 1 plus the square root of 33, hit enter, divide it by 3, and you should get 2.25. And then do 1 minus the square root of 33, hit enter, divided by 3, and that should land you at a negative 1.58. And these would be our approximate answers. There you go. All right, let's scoot on down to example 4. We'll take this one from top to bottom. And again, I would definitely recommend, let's pause the video now and you try this left-hand column and check yourself by the solution key. All right, so down below in example 4, it says the height h in feet from the ground of a falling rock t seconds after being dropped from a 50-foot cliff is given by this equation. Part A wants to know how high above the ground is the rock after 1.5 seconds. So h equals negative 16. I have a time here, so I'm going to plug that 1.5 in for my t. So 1.5 squared plus 50. And then this is just a matter of, you can just put this in your calculator all at one time, and you should land at 14, height measured in feet. That would be our final answer there. Part B wants to know how long is it going to take the rock to fall to 10 feet above the ground, and it's going to write your round your answer to 2 decimal places if necessary. So this time they're giving us a height of 10 feet. So in place of h, I'm plugging in 10, and I'm going to be solving. I want to know how long. I'm trying to figure out a time. I'm going to be solving for t. So I only have one t in this problem, so I'm going to treat it like a normal equation. Letters on one side, numbers on the other. So 10's over there all by itself. I'm going to take 50 over to join it. 10 minus 50 is going to give me a negative 40 equals negative 16 t squared. I'm going to divide both sides by negative 16. So then I have t squared equals, I can reduce that. I can leave it as a fraction, or I can just go ahead and reduce it. I think I'll just go ahead and reduce it. It comes out to be a nice decimal, so 2.5. And then to get t all by itself, just like we were doing previously, take the square root. So you get t equals plus or minus the square root of 2.5, which will give you plus or minus 1.58. You're talking about time, so in our case here, only positive time makes sense, so a positive 1.58 seconds. Okay. And then lastly here in part C, it wants to know how long is it going to take for that rock to hit the ground. So think about it. If the rock hits the ground, what's its height? You agree it would be 0. So height of 0 equals negative 16 t squared plus 50. I'm trying to solve for t. So 0 is over there all by itself. Let's take 50 over to join it. Numbers on one side, letters on the other. So negative 50 equals negative 16 t squared. I'm going to divide both sides by negative 16. T squared equals 3.125. I'm going to take the square root of both sides. And again, we're talking about time, so it is plus or minus, but negative time does not make any sense. So you would get 1.77 seconds. Final answer there. All right, let's flip it over then. Next page. So as I mentioned, solving quadratics so far, we've talked about factoring previously, and we revisited it here in the first example. Then now we've introduced the square root property, and we use it when we just have n squared equaling some number. But unfortunately, those have some limitations, and that requires then yet another way to be able to solve quadratics, and this is where the quadratic formula comes into play. And so remember, quadratic form is of this right here. I'm boxing it in, ax squared plus bx plus c, where a, b, and c are just numbers, but that a value can't equal 0 because you got to be quadratic. But essentially you're going to use the quadratic formula whenever you're not able to factor. Okay, this is the quadratic formula down below. I like to read this as opposite b instead of negative b. I read it as opposite b plus or minus square root b squared minus 4ac all over 2a. All right, and that's going to give us our two solutions. So the first thing, whenever you're solving a quadratic, it always needs to be equal to 0. Okay, and you'll know to get it equal to 0 whenever you have an x squared and an x term. Okay, on the previous problems we just had an x squared, so we didn't necessarily have to get it equal to 0. We had letters on one side, numbers on the other. But the moment you have an x squared and an x term, you want to get everything all on one side equal to 0, so that personally I always try to factor first, and then if it won't factor, let's use quadratic formula. Okay. Now, down below in example 5, I am specifically telling you to use the quadratic formula because I want you to practice using the quadratic formula. In letter A, there's no other way to solve that one, but letter B could actually be solved by factoring, okay? I'm going to do letter A with you. I've shown all my work in letter B on the solution key. Let you try that one on your own. That'll be an easier one to do by yourself with the quadratic formula. All right, so if we're coming over here to letter A, I want to solve using the quadratic formula. I need to get it equal to 0, and I know that because I got x squared and an x. So I'm going to pull that 18 over. So now I have x squared plus 6x minus 18 equal to 0. Okay. And again, if I just revisited this, real quick, as far as, just saying, hey, could I factor this? The only way to multiply give me x squared, x and x. I'm trying to get a 6 in the center, so think about the ways to multiply to give you 18. You got 1 times 18, 2 times 9, and 3 times 6. You want to be able to add or subtract these to be able to get you a 6. And 1 and 18 is definitely not going to give you 6. You add it, you get 19, subtract it, you get 17. So that one's out. 9 plus 2 is 11. 9 minus 2 is 7. So that one's out. 6 plus 3 is 9. 6 minus 3 is 3. That one's out. It can't be factored. So when you can't factor, this is when the quadratic formula comes into play. So let's come under here and let's identify our A, B, and C. Here's my A, my B, and my C. A, B, and C are your numbers, so your A then is an imaginary 1 sitting there. All right. Quadratic formula above, it says, I'm going to put it so you have it right here. This is what I'm referencing. I'm substituting into this formula. So it says opposite B. So B is 6, so opposite B, negative 6. Plus or minus square root B squared minus 4 times A times C all over 2a. All right, so now I just keep going through and let's clean this up. So I have negative 6 plus or minus the square root, 6 squared, 36. Negative 4 times 1 is going to give me negative 4 times negative 18. That's going to give me a positive 72. On the bottom, that's 2. All right, keep cleaning up. So I have negative 6 plus or minus the square root of 108. Okay, all over 2. All right, we're going to use our techniques for reducing that 108. It's not a perfect square root, but we're looking for the highest number in our list that'll divide evenly into 108. And that would be 36. 36 times 3 will give you 108. Square root of 36 is 6, so it comes outside. 3 stays inside, all over 2. Final answer then, 2, 6, and 6 are all outside, and they all have a 2 in common. So I'm going to divide each of those by 2. For a final answer then of negative 3 plus or minus 3 square root of 3. It's all over 1, but you don't need to worry about writing that. And then as far as writing what the approximate, so these would be your exact solutions. 3 plus 3 square root of 3 and 3 minus, I'm sorry, negative 3 plus 3 square root of 3 and negative 3 minus 3 square root of 3. Approximate solutions would be to put those in your calculator, and you should land at 2.20 and negative 8.20. Those would be, like I said, our approximate answers. Okay. All right, stop the video, try B on your own. I'm going to flip it over to the last page, and I'm going to do letter D with you and example 6. Okay. So in letter D, it is already equal to 0. So I'm going to, like I said, I'm going to use my quadratic formula. So my A, my B, and my C. Opposite B. So right now B is negative 2. So the opposite of negative 2, positive 2. Plus or minus square root B squared minus 4 times A times C all over 2 times A. All right, so I'll keep cleaning up. So I have 2 plus or minus the square root. I've got 4 minus 60 all over 10. That'll give me 2 plus or minus the square root of negative 56 all over 10. Now from here, there's really no need for me to go any further, because if you think about it, remember, we can't take the square root of a negative number. So at this point then we say that we have no real solutions. And because reducing that further would require us to talk about imaginary numbers, and you won't talk about that until you get into your pre-calculus class. So at this point, we're just going to stop right there, because I can't take the square root of a negative number, and we'll say that we have no real solutions. I just wanted you to see that, what would happen if you had a negative underneath the square root. All right, let's bump on down to example 6 together. In example 6, it says that a local model rocket club launches a rocket that follows the path of this given by this equation. T represents time in seconds after the launch, and h is the height of the rocket t seconds after it's been launched. Okay, so part A says the phrase "when the rocket will hit the ground" contains the word "when." Does "when" indicate that we're trying to determine the height of the rocket or the time? Hopefully you agree with me and say, hey, that has to be, make sure I didn't mess that up there. Yeah, hopefully you agree. Well, anytime we're talking about when, we're talking about a time. So let's move on down then to part B. Part B says, when the rocket hits the ground, what is the value of the height? Substitute this value into the equation and solve it. Okay, so when the rocket hits the ground, it's got what height? Just like we saw in that previous problem, height would be 0. So I am setting my equation here equal to 0. And from here, I am going to solve. I'm going to go ahead and still use my quadratic formula, because I got some really big numbers here. So remember your A, your B, and your C. So opposite B, so a negative 170 plus or minus square root B squared minus 4 times A times C all over 2 times A. All right, I'm going to keep going. So that gives me negative 170 plus or minus the square root. That 170 squared should give you 28,900. And then 4 times 16 times 5 should give you 320. And that'd be positive, because you got a negative times a negative is a positive times 5. So that should give you 320. All over on the bottom, a negative 32. All right, so I'm going to go another step here. I got negative 170 plus or minus the square root. Clean up that inside there, and I have 29,220 all over negative 32. So then that's giving you two answers that you then need to explore and see which or both work for us. So I have negative 170 plus the square root of 29,220 over negative 32. And then I have negative 170 minus the square root of 29,220 over negative 32. I've mentioned this before. If you want to put this in your calculator all at one time, you got to have parentheses up top. Personally, I just like to type in the top, hit enter, and then divide it by negative 32. When you do the addition, you should land at a negative 0.03 seconds. So we're talking about time, so that one can't work. When you do the subtraction, you should land at 10.65 seconds. And so that's, again, that's the only time that makes sense as positive time. Okay. Example 7 lets you repeat this process, with a different problem, but it's wanting when's that droplet going to hit the ground, and so your height would be equal to 0. All right, that finishes up this section. Thanks a lot. Bye.